So in this related rates problem, we're going to find the speed of a piston, right? So this piston right here, and this piston is going to move left and right as the crankshaft here spins at a rate of 200 revolutions per minute. And so since we're looking for the speed of, or the velocity of the piston, right, the piston's going to be traveling along the x here, and so we're going to be looking for dx dt. Okay, and so we need to somehow look at this and relate it so that we can get dx dt. And so we have a triangle here. We know the revolutions per minute, and we can convert the revolutions per minute to radians per minute by multiplying by 2 pi. So we're going to find dx dt when theta equals pi over 3 and d theta dt equals, well, there's 2 pi radians in a revolution, so 200 times 2 pi gives me 400 pi. Okay, and so somehow we're going to have to relate theta and x together so that we can take the time derivative of it to find dx dt. And so we have a triangle here. It's not a right triangle, so we're going to have to use law of cosines. And so since my angle is opposite the side 7, we can say that 7 squared is equal to 3 squared plus x squared minus 2 times 3 times x cosine theta. And so we'll get 49 equals 9 plus x squared minus 6x cosine theta. And so we don't want to plug in these values yet. We don't know d theta, or we don't have d theta dt in there yet, and we don't have dx dt in our equation. So we're going to take the derivative first, then we make our substitutions. That's important in related rates. We're going to first take the derivative of both sides with respect to t, then we substitute the values we know. And so when we take the derivative, we get 0 equals, derivative of 9 is 0. Derivative of x squared with respect to time is going to give me 2x dx dt. And on this piece here, we're going to have to use the product rule. And so we'll get negative 6 times cosine theta dx dt. So that's when we take the derivative of x with respect to t, leaving cosine theta by itself. Now we're going to take the derivative of the second piece, which is cosine, and so that's going to give us a negative sign. And the negative with the negative gives us a positive. 6x will stay the same. Sine theta d theta dt. Okay, and so now we have our equation. We have dx dt, we have d theta dt. We're going to solve the equation to get dx dt by itself. So to do that, we're going to get everything with dx dt's onto one side. And so I'm going to skip some steps. We'll get dx dt equals 6 cosine theta minus 2x will equal 6x sine theta d theta dt. And so dx dt equals 6x sine theta d theta dt all over 6 cosine theta minus 2x. And so we have theta, we have d theta dt, we don't have x. And so we're going to use the law of cosines to figure out, well, when theta equals pi over 3, what does x equal? And so we'll have 49 equals 9 plus x squared minus 6x, and then cosine of pi over 3 is 1/2. And so this is going to give us 0 equals x squared minus 3x minus 40. So factoring this, we'll get 0 equals x minus 8, x plus 5. And so two possible solutions for x would be x equals 8 or x equals negative 5. And since we're talking about a distance here, negative 5 we'll ignore. And so x equals 8 under these conditions. And so now we can just substitute. So we have 6 times 8. Sine of pi over 3 is root 3 over 2. d theta dt is 400 pi. That's all over 6 times cosine theta. Well, cosine theta is 1/2. So cosine of pi over 3 is 1/2 minus 2 times 8. And when we plug this into a calculator and solve, we'll get approximately negative 4108. And our units would be inches per minute here. And so since we're talking about velocity, since we got a negative, this tells us that at this moment in time, our piston is actually moving in this direction because of that negative sign. So there's example 3. Are you kidding me?